This is another conservation of energy problem. I got a bullet that's moving at some speed. It strikes a steel plate and stops. All its kinetic energy is converted to thermal energy, right? So right there tells you how to set up the problem. So all of the kinetic energy is turning into thermal energy. And we know kinetic energy is half mv squared, and we know thermal energy, right? In this case, it's all the same phase, right? It's all a solid. It's mc delta t. So all I have to do is set those two things equal to each other, and I can solve, right? So K is 1/2 mv squared, and Q is mc delta t, right? So you could do it two ways. You could either solve for the kinetic energy and then set it to this, and then temperature change, right? So I'm trying to solve for delta T. So you could solve for this and then just divide over MC. Or, right, you could do the algebra first, and you can see that M's cancel out. And if I want T, all I got to do is divide the C over, right? So that's half V squared divided by C will give me my temperature change. And that's it. Yeah, that's not that bad, right? So let me check just to make sure. Half mv squared mc delta t, right? And then you divide that over. Yeah, that's basically it. And so it wants it in Celsius. Because you're getting a delta t, you don't have to convert anything. So normally T is in Kelvin, but this is delta T. And remember, Kelvin and Celsius have the same scale. So our delta T is already in base units.